Imagine a bustling city. Skyscrapers touch the clouds, people go about their day. Suddenly the ground starts to tremble, buildings sway, panic erupts. But amidst the chaos, one skyscraper stands firm. It weathers the earthquake. How is this possible? The answer lies in a remarkable invention, the shaking table. The ability of certain buildings to withstand earthquakes is no accident. It's the result of meticulous planning and rigorous testing. Engineers use sophisticated tools to simulate the forces unleashed during an earthquake. One of the most important tools is the shaking table. Shaking tables are massive platforms. They recreate the ground motions of an earthquake. Engineers use them to test the resilience of buildings and other structures. By subjecting scale models or even full-sized components to simulated earthquakes, they can identify weaknesses and improve designs. These tables are incredibly powerful. They can move in all directions, horizontally and vertically, to mimic the complex forces at play during a seismic event. This allows engineers to study how different designs will behave under stress. Shaking tables are marvels of engineering. They use hydraulic actuators or electric motors to create movement. Sensors and computers precisely control the table's motion. This replicates the specific frequencies and amplitudes of real earthquakes. Throughout the test, sensors attached to the structure collect data. This data includes things like strain, displacement, and acceleration. By analyzing this information, engineers can identify vulnerabilities and make necessary adjustments to the design. Many iconic buildings around the world have been tested on shaking tables. One example is the Los Angeles City Hall. After suffering damage in the 1994 Northridge earthquake, it underwent retrofitting based on shaking table tests. This ensured its safety in future earthquakes. Another example is the Taipei 101 skyscraper in Taiwan. This building, once the tallest in the world, was subjected to rigorous testing on a massive shaking table. The test confirmed its ability to withstand powerful earthquakes and typhoons. Section 5. Saving lives. The impact of earthquake-resistant design. The importance of earthquake-resistant design cannot be overstated. Buildings designed and tested this way save lives. They minimize damage and protect occupants. By understanding how structures behave during earthquakes, we can create buildings that are much safer. While we cannot prevent earthquakes, we can design buildings that protect lives and minimize damage. The goal is not to make buildings completely indestructible. Rather, it's to ensure they can withstand seismic forces without collapsing. This gives occupants time to evacuate and minimizes the risk of casualties. Section 6. A safer future, the importance of universal testing. While shaking table testing has become more common, it's not yet mandatory for all buildings. However, there's a growing consensus that such testing should be a requirement. Every new structure, especially in earthquake-prone areas, should undergo this rigorous evaluation. Imagine a world where every building is designed to withstand earthquakes. It's a world with fewer casualties, less destruction, and a quicker recovery after a seismic event. Section 7. Beyond the shake, broader applications of shaking tables. Shaking tables are not just for skyscrapers. Engineers use them to test a wide range of structures, including bridges, dams, and even nuclear power plants. They are crucial for assessing the seismic vulnerability of critical infrastructure. By simulating various earthquake scenarios, engineers can identify potential weak points in the design and construction of these structures. This allows for improvements that make them more resilient to seismic activity. Section 8. Your role in earthquake safety. Earthquake safety is everyone's responsibility. Learn about the earthquake risk in your area. If you're planning to build a new structure, insist on earthquake-resistant design and testing. Support policies that promote earthquake safety. Remember, even small steps can make a big difference. By raising awareness and advocating for change, we can create a safer future for everyone. Section 9. A call to action. Building for a resilient tomorrow. Shaking tables are more than just scientific instruments. They are tools that save lives. By embracing innovation and rigorous testing, we can build a future where earthquakes cause minimal damage and disruption. Let's work together to create a world where buildings stand strong, even when the ground beneath them shakes.